Hey kids, Mr. Murray here on Mr. Murray's Mathland channel, and we're talking today about solving some exponential equations, taking it up a notch from the type we've been doing. So take a look at number one here. We're going to solve for x algebraically, and then we'll use our calculator to find its value to 3 decimals. And that means we're going to try to isolate x, solve for x, without touching our calculators, unless we really need to. But I don't want to use any decimals in intermediate steps here. I only want to round at the very end. Otherwise, I might round off and then use that to get a new answer and lose a little bit of accuracy. So the goal is don't touch the calculator until you absolutely have to. Okay, so taking a look at this equation here, we have negative 3 times 2 to the x minus 7 plus 80 equals 5. X is in the exponent here. So first thing I want to do is try to isolate the exponential portion of this. I want to try to isolate that 2 to the x minus 7. So I'm going to do as much basic algebra as I can. First thing, subtract 80 from each side. Should be easy enough, right? Just going to move that over there. We'll have negative 3 times 2 to the x minus 7 equals 5 minus 80 is negative 75. Then my exponential expression is not isolated yet because I have a coefficient of negative 3. So I'm going to divide by negative 3. Just algebra 1 here, kids. And now we have 2 to the x minus 7 is equal to positive 25. Okay, so this is really where my algebra 1 kind of hits the wall, because I have 2 to the x minus 7 is equal to 25. And the way we've done problems before this is I would try to rewrite both sides with the same base. You know, over here maybe it would be an 8 or a 16 or 1/16, something, but 25 is not a power of 2. So this is what logarithms are really for. And so what I'm going to do is I'm going to basically take a logarithm of each side, kind of how I divided both sides by negative 3 or subtracted 80 from each side. I'm going to take a log of each side, and one way to go about this is to, if you're dealing with base 2, that's 2 to the x minus 7, then that's the log you want to use. I'll do log base 2 of each side. So I'm going to take log base 2 of each side. And on this side, log base 2 of 2 to the x minus 7, they cancel each other out. There's that inverse relationship of logs and exponents that leaves you with x minus 7. Now over here you have log base 2 of 25, which that I don't know what that value is without a calculator. But I'm now going to solve for x, add 7 to both sides. So it will be log base 2 of 25 plus 7. That's the algebraic expression for what x is equal to. And now to get that decimal value, I'm going to use the change of base formula, because my calculator, most basic scientific calculators only have a base 10 and a base E, natural log button. So no problem. That's what we got the change of base formula for. So on this side, here we go. I'm going to call this, remember you can convert to base 10 or to natural logs. So I'll go, why not base 10? Log of 25 divided by log of 2. Remember the base goes in the basement there. So, and that's another equivalent expression for what x is equal to. But that's the one I'm going to use on my calculator now to get that decimal value. So this is approximately equal to, so here we go, log of 25 divided by log of 2, and then add 7. And to 3 places that would be about 11.644. There we go. And I will just say that when I was in school, we learned it a little differently, and it's all the same. So it's really the first few steps, the algebra 1 steps were the same. And I'll just show you this. Maybe you'll prefer this, maybe not. But I think it's good to show both points of view and why they're really the same. when I was right here, the same step we were at right here and here, we were taught to take the log of both sides, but our teacher would say, hey, don't bother with base 2 because you don't have a base 2 button on your calculator. It's base 10 or natural log, kids. So we would take base 10 of each side. So I would just take log of each side. But what doesn't work out so nicely is that on this side now, it doesn't just cancel out. Log base 10 of 2, they're not the same base, they don't cancel each other out. But what it did allow you to do was to use the power property of x minus 7 and pull that to the front so that you would now have x minus 7 times that log of 2. And again, that's base 10 when it's an unwritten base. And then to solve for x, we would divide both sides by log of 2. And you're left with x minus 7 equals this log of 25 divided by log of 2. And hopefully you see it taking shape so that x is log of 25 over log of 2 plus 7. When you add 7 there. So you get the same exact thing. It's just like you're using base 10 right off the bat, whereas on this one, maybe it makes the solving a little bit nicer, but then you have to use the change of base formula to go to base 10 later. About the same amount of steps, and they're equally good. So just wanted to point that out in case you bump into a teacher next year who does it one way versus the other, or a textbook that shows it one way versus the other, or your teacher last year may have touched upon it. So either way, it's all good to me. And we'll just show you one more example here, just so, can't hurt to see one more. Again, you've got your variable there is in the exponent there. You want to isolate that exponential portion. I want to isolate that e to the 3x. So I got some algebra here to do before then. I'm going to cross multiply both sides here. And you got a negative on this right side. So, just remember, be careful, assign it to one of those two. So I'm going to do negative 2 times that quantity of 4 minus e to the 3x, and that's going to be equal to 6 times 9, which is 54. This negative 2 you could distribute now, or you could divide by it. I suspect a lot of people would distribute. Does not matter to me. If you distribute, then you're right here. You add 8 to both sides. Again, we're trying to isolate that exponential, so I'm doing as much algebra 1 as I can. 54 plus 8, that's 62. Still not isolated. One more algebra 1 step I can do. Divide by 2. And now you've got e to the 3x is equal to 31. And there's my algebra 1 has run out. So time to use some logs, kids. That's how we get those variables out of the exponents. And if you're dealing with base e, then hey, that's natural log all the way. I'm going to take the ln of each side, the natural log of each side, and it's beautiful. Ln of e to the anything is that exponent. So ln of e to the 3x is 3x, and on this side it's ln of 31. Solve for x, divide both sides by 3. And just be careful where you place your division signs, your quotients, that it is the ln of 31 divided by 3, not 31 divided by 3 on the inside of a log. So two very different things. There's the exact value for x. And now to get a decimal approximation for ln of 31 divided by 3, ln of 31 divided by 3, and you get about 1.145 when you round to 3 decimal places. And so there we go, kids. Two examples, 2 different bases. So hopefully this helps a little bit if you're having any trouble with it. If not, see me for help, ask questions, and you'll get there. Good luck, kids.